Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with thermodynamics of chemistry. In this topic, this is the lecture number 23, and in this lecture I will explain you what is enthalpy and heat capacity. So let us take first of all enthalpy. The symbol of enthalpy is H. So we represent enthalpy with H. At constant pressure, when system expands, the volume changes. At that time, the total heat content of a system at constant pressure is equivalent to internal energy E plus PV work. So the total energy of the system at constant pressure is known as enthalpy. Okay, so this is what enthalpy means. Okay, so we write H is equal to E plus PV. In this equation, E, P and V are state functions. Therefore, H is also a state function. Suppose in first condition we write H1 is equal to E1 plus P1 V1, and for second condition or second state we write H2 which is equal to E2 plus P2 V2, then delta H is equal to H2 minus H1, or we can write final minus initial, or sometimes we write HP minus HR, product minus reactant, considering reaction. So delta H is equal to, substitute values, E2 minus E2 plus P2 V2 minus, minus bracket E1 plus P1 V1. So delta H is equal to E2 minus E1 plus P2 V1 P2 V2 minus P1 V1. So delta H is equal to delta E plus P delta V plus delta P into V. But delta P is 0 because this occur at constant pressure, because pressure is constant. Therefore, delta H is equal to delta E plus P delta V. So this is an equation used to find out enthalpy change from internal energy change and work done. Okay, so we write delta E is equal to, you know that delta E is equal to, delta E is equal to Q minus W according to first law of thermodynamics. And you know that P delta V is equal to W. And delta H is equal to delta E plus P delta V. So we substitute values of all. So delta H is equal to delta E is equal to Q minus W, and P delta V is also W. So W will be cancelled. So delta H is equal to heat changes at constant pressure. So for exothermic reaction, as Q is negative, delta H will be negative. And for endothermic reaction, delta H will be positive. Now we know that P delta V is equal to V2 minus V1. Okay, and PV is equal to nRT. Now number of moles related to volume, therefore we can write P delta V is equal to N2 minus N1 RT. R and T are constants, and therefore we write delta H is equal to delta E plus delta N of gaseous molecules only. RT, R is a gas constant. So this is also one of the important equation used to determine enthalpy change from number of moles are given, temperature is given, and etc. Okay, so this is all about enthalpy. Now we will take heat capacity. So another topic is heat capacity. So next topic is heat capacity. And the symbol is C. By heat capacity of a system, we mean to absorb heat and store energy. As the system absorbs heat, it goes into the kinetic motion of atoms and molecules contained in the system. This increased kinetic energy and raise the temperature of the system. So if Q calorie is the heat absorbed by mass m, and the temperature rises from T1 to T2, then the heat capacity C is given as C is equal to Q upon m into T2 minus T1. So this is what heat capacity means. So the heat capacity of a system is the heat absorbed by unit mass in raising the temperature by 1 degree at a specified temperature and condition. So C is equal to Q upon T2 minus T1 if m is equal to 1, or Q upon delta T, and this is known as molar heat capacity. Okay, it is called molar heat capacity. So this is it in this lecture. Thank you so much.